Okay, so today we're going to be covering section 2.6, which is going to be properties of equality and congruence, and then we're going to be studying a lot of properties today. So this is a section where you're just going to have to study what these properties are in order to be successful on a test or quiz. Okay, reflexive property. Reflexive really means I'm going to have the exact same thing on both sides. So segment AB is equal to segment AB. It's the exact same thing on both sides. I could write it very simple, like 3 is equal to 3. The exact same thing on both sides, okay? So if this says the measure of angle A, I'm going to write the measure of angle A over here. This is the reflexive property, okay? It also works for congruent. So if I'm talking about segment AB, I can say it is congruent to segment AB. It doesn't matter if it's equality or congruence. It's whatever is on one side of the equation is the exact same thing on the other, okay? The symmetric property. Symmetric property is going to involve two pieces of information. It's going to say if A is equal to B, then B is equal to A. So what happens here is I'm really just taking my information and I'm switching the order. I'm just flipping them. Okay, so they give us some examples with segments. If AB is equal to CD, then CD is equal to AB. So I'm just flipping them. If the measure of angle A is equal to the measure of angle B. If I switch that information, what would it be? It would say the measure of angle B is equal to the measure of angle A. Okay? Likewise, it works with congruence as well, using those congruent symbols in there. So if angle A is congruent to angle B, then I can assume that angle B is congruent to angle A. Okay? The transitive property has to have at least 3 parts to it. It can have more, but at least 3. Okay, so as soon as you see that there's 3 pieces of information in here, it's going to be a good indicator that it should be the transitive property. Okay, what I look for with the transitive property is overlap. Okay, so this is what I mean by overlap. If AB is equal to CD and CD is equal to EF, then AB is equal to EF. It's really an order thing. These 2 pieces are the same. I can take them out. They're overlapping and just say the first is equal to the last. That's our transitive property. So let's try another one. If the measure of angle A is equal to the measure of angle B and the measure of angle B is equal to the measure of angle C, then what can we assume? Well, what's the overlap? The overlap is right here. They're right next to each other. They're the exact same. If I take them out, what am I left with? The measure of angle A is equal to the measure of angle C. Okay? Over here, it's the same idea, only now they're using congruence instead of the equal sign. So if angle A is congruent to angle B, and angle B is congruent to angle C, it's really very similar to what we stated over here. We find the overlap, we cross it out, and we would say what? Angle A is congruent to angle C. Okay? So on the next section, we're just going to practice. Name the property that illustrates each. If you want to pause the video here and try them, go ahead, or you can do them with me. So this one, exact same thing on both sides. Which one is it? Is it reflexive, symmetric, or transitive? This one's going to be our reflexive property. And I need to write prop at the end for property, or you could write it out. Okay, if angle P is congruent to angle Q and angle Q is congruent to angle R, then angle P is congruent to angle R. Well, I see there's 3 pieces of information. There's an overlap right here. What property is this? It is the transitive property. Okay? If DE equals FG and FG equals GH, then DE is equal to GH. Looks like we've got that overlapping piece once again. So yes, this is the transitive property. Okay? The next one, angle P is congruent to angle P. We're just going to say this is the reflexive property. It is the exact same thing on both sides. Okay? The next one, if the measure of angle S is equal to the measure of angle T, then the measure of angle T is equal to the measure of angle S. All they did is they took this information and they switched places. So this is going to be the symmetric property. Okay? Properties, algebraic properties of equality is the next section. Okay? You've used these before. Okay? So if they're giving me an equation like this, Okay, looking at that equation, I'm going to ask you, how would we get x on a side by itself? Well, we would need to add 3 to both sides. So this is called the addition property of equality. This means I add the same number to both sides of a true equation to produce a true equation. When I add that number to both sides, what I'm left with is x is equal to 15. That's my answer. But what we're showing is that we're adding the same value to both sides of the equation, both sides of the equal sign. Next one would be subtraction. So this is where we're going to subtract the same number from both sides of the equation. Okay, so like this one, x plus 2 equals 8. How would I get x on a side by itself? Well, I would be subtracting 2 from both sides. So that's our subtraction property of equality. Okay, multiplication, same idea. We're going to multiply each side of the equation by the same non-zero number. Okay, so like this one, they have half x is equal to 5. I would want to, in order to get rid of that fraction, I would want to multiply by the reciprocal, or really for this one, it's just the denominator. I'm showing that I'm multiplying both sides of my equation by 2, so this is the multiplication property. Division means I'm going to divide each side of the equation by the same non-zero number. Okay, so from here, if I have 8x is equal to 24, how do I solve? I divide by 8, and then I would get x equal to 3, but I'm showing that I'm dividing on both sides. Okay, substitution is going to be when I substitute a number for a variable in a true equation to produce a true equation. Okay, you can think of this as replacing something. Okay, if you think about Mrs. Olson having a substitute teacher in class, Mrs. Olson isn't here. She's being replaced by another teacher for the day. Okay, so we're replacing something. What they're saying here is if x equals 7, then I have the equation 2x plus 4, that would be equal to, well, I can substitute the 7 in for the x, so it would look like 2 times 7 plus 4. This is an example of substitution. I'm replacing the x with the 7 that it was equal to. Okay, the next section, we're going to name the property that justifies each statement. Okay, so I'm going to say, this is the hypothesis. This is what we're starting with. They want to know, how do we get to the conclusion? We don't work backwards. It has to start here. Okay, so you can cover up that second piece and just say, okay, if I have the equation of 6x equal to 24, what do I need to do to solve there? If you say divide, you are correct. You are using the division property. Okay, do it the same way next time. Okay, they're saying 7x plus 7 is equal to 28. How do we get to 7x equal to 21? Well, if I cover this up, what would you do from here? You would subtract 7 from both sides. So this is called the subtraction property. Okay, if you want to pause and try the next two, go ahead, or you can work with me. If half x is equal to 3, then x is equal to 6. They want to say, how do I get x on a side by itself? How do I get rid of this fraction? Well, it's very much like our example property up here. When we were multiplying, we're going to multiply both sides by, if you said 2, you've got it right. So this is the multiplication property. Not because we multiplied by 2, but just because we were multiplying by the same value on both sides. Okay, on the next one, it's saying if x is equal to 2, and 2x minus 1 is equal to 3, what tells us we could just really say it's 2 times 2 minus 1 equal to 3? What it looks like is this x is no longer there. Now there's a 2 there. It's been replaced by another number, okay? Well, it's been replaced by the x equal to 2, so this is substitution. Substitution property, okay? We're going to move on to the back page, and when we get on the back page, we're going to start writing those properties out in proof form. You guys did this in Algebra 1, okay? So it says justify each step in the algebraic proof. What they're doing is they're really just solving an equation on this side, and we have to justify each step is what we're doing, okay? The first step in any proof is going to be called the given. This is what we were presented with. That's what we're starting with, okay? Step 2, what I noticed from here to here is there's no longer a fraction over here. So how did they get rid of that fraction? Well, they would have needed to multiply each side by 5. So this would be our multiplication property. Okay. Now, if I'm looking at this equation, what would you do next to solve? Cover up the rest of it. What would you do next to solve? I see I have this number outside of parentheses, so I'm going to bring this number through. What do we call that property? It's not the multiplication property. It's a little bit more specific. It's called the distributive property. Okay? From this step to this step, what do you notice? Well, I noticed that I had a 5x and a 2x, and now I only have 3x. So what that tells me is they did something with the x's. So I'm looking at this equation. I want the x's to one side. That means I'm going to bring this 2 over. And how did I bring the 2 over? I had to subtract. So this is the subtraction property. It's okay with me if you want to abbreviate. Just make sure you abbreviate far enough that I know you're using subtraction and not substitution. If you just write sub property, I don't know which one you're using, and I'm not going to guess. Okay? All right, from this next step, what would you do to solve? If you said add 10, you're correct. We are going to have 3x equal to 18. Then we used our addition property. And the last step, if I have 3x equal to 18, we would divide each side by 3, and that's where we get this x equal to 6. So we say this is the division property. Okay, what I would like you to do from here is pause the video, try the next one, and then check it. Okay, so when we go through here, this first step is the given. The second step, what I noticed, kind of tricky, they put these two values together, and some students would call that subtraction, but did I actually subtract the same value from both sides of the equation? I didn't. What I did is I put these two together. Sometimes we'll call it combine like terms or simplify, but since combine like terms and simplify is not a property, we really say we're putting them together and replacing it with a 99. I use that word replace. This is going to be our substitution property. Okay? From here, what would be our next step to get 9y on a side by itself? I would subtract the 99, so I'm using the subtraction property. Notice I didn't write sub with either one. I wrote them out far enough so we know this is substitution, this is subtraction. Last step would be divide by 9, and I get, this is my division property. Okay, then they give us two that we're going to practice together. Okay, so on this one, what we're going to do is we're just going to start by writing out our given. Okay, from here, what I want to do is start by moving my x's. So I would subtract that x on both sides. You don't have to show that work if you don't want to, but step 2 we would rewrite as 4x minus 12 is equal to 32. And step 2, this is going to be our subtraction property. From there, we want to move that 12 over to the other side. So we're going to say 4x is equal to 44. We use the addition property. And then the last step here, to get x on a side by itself, I would divide by 4, and I'm going to end up with x equal to 11, and we use the division property. Okay? The very last one, number 13, step 1 is always given to us. Okay? Let's go for step 2. Okay, what are we going to do in step 2? I'm going to leave my negative x out here. It looks like I have this negative 2 outside of parentheses. I'm going to pull it through. That's called distributive property. The negative has to go with it. So negative 2 times 9 gives me a negative 18. And negative 2 times a negative 8x gives me a positive 16x equal to 12. This, once again, was our distributive property. We don't want to say multiplication because we didn't multiply on both sides. Step 3, we are going to combine these x's right here. I have a negative x and a 16x. That gives me 15x minus 18 equal to 12. And since I combined them, I don't write combine like terms. This is where we use that word substitution property. Okay, my next step, I would add this 18 to the other side, and that's going to give me 15x equal to 30. This is my addition property. And then my last step, what would you do to solve for x? You would divide by 15. I'd get x equal to 2 using my division property. Today's assignment is going to be a worksheet. We're going to cross out a couple, so I will cross it out on the sheet for you.